asymptotes occur when a graph approaches a certain value, but never actually gets to that value. So for example, right here on this graph, you can see that the graph approaches -2, but it never actually gets to -2. So we have what is called an asymptote right here at -2. It approaches -2, never actually gets there. And down here, it also approaches, from the left, it approaches -2 and never actually gets there. And the same thing on this side, it approaches 2, never gets there. And from the right, it approaches 2 and never gets there. And so these two are called vertical asymptotes. You have x equals -2 is a vertical asymptote, and x equals 2 is another vertical asymptote. We also have horizontal asymptote right here. It looks to be about y equals -2 is a horizontal asymptote. So this is where the graph gets closer and closer to -2, but never actually gets there, closer and closer on this side to -2, and it's approaching from below, never actually gets to -2. So we have these what are called asymptotes. Okay, and you can graph them on your calculator to figure out where the asymptotes are, but there are also some other ways. So let's go over the other ways. So let's say this is our function, right? And we want to know where its asymptotes are. So let me write that down. Y equals 2x squared, and I'm going to write it in descending powers of x. It was -x squared plus 4. Okay, so the way to find asymptotes, let's do let's do horizontal asymptotes first, because they're the easier ones. Okay, horizontal asymptotes. So the way to do a horizontal asymptote is to take a limit, and perhaps you don't know what that means, but this is why I wrote it in descending powers. What you do is you cancel out everything except for the highest power. Okay, so we'll, sorry, not equals, but oops, I erased everything. Y equals 2x squared -x squared plus 4. I don't mean erase, but just take out everything that is not the highest power of x. Okay, we're going to take a limit, so that just means we're going to look at end behavior, and end behavior is determined by the highest power of x. So in the top, we take the highest power of x, which is this term, and the bottom, we want the highest power of x, which is this term. The plus 4 doesn't matter. Okay, so once we get that, we are going to try to reduce it. So how does this reduce? It reduces to, we can cancel out the x squareds, and we get -2. Okay, and once we get -2, we always say y equal, for horizontal, it's always y equal. Y equals -2 is our horizontal asymptote. So let's look at another example. Let's say we have a function, let me grab a different color here, g of x equals, let's say, 3x to the 5th minus 7x plus 10 over, let's say, 7x to the 5th plus 9x squared. Okay, so the first step is going to be to take the limit, and doing limits, we don't need anything except for the highest power of x. So we'll take 3x to the 5th is the highest power, and 7x to the 5th is the highest power term. Okay, so once we get the highest power terms, we reduce it. This equals 3/7, and so our horizontal asymptote is y equals 3/7. All right, so this would be the horizontal asymptote. That means on a graph, you go to 3/7. Okay, let's say this is 1 right here. 3/7 is going to be about here, and this line will be your horizontal asymptote. Okay. Okay, some other things can happen with horizontal asymptotes. They don't always have to end up like that. Let's say that we have y equals 3x squared plus 2x over 7x. Okay, what happens when we take a limit here? we want the highest powers of x, 3x squared over 7x. And what do we get? We get, when we reduce this, we get 3/7 x. Okay? And so this is, we still have an x in our answer. All right? And so when this happens, we do not have a horizontal asymptote. Y equals 3/7 x is our asymptote. Okay, this is not a horizontal line. And then what else can happen? Y equals, let's say, maybe, let me use a different color. Blue. Y equals, let's say we have 10x to the 5th, and on the bottom we maybe have 12x to the 6th plus 3. Okay, when we take a limit here, we have 10x to the 5th over 12x to the 6th, because we just look at the terms that have the highest power of x. We'll reduce this and get 5 over 6x. And notice we have x's in the denominator. Okay, so when you have extra x's left over in the denominator and not in the numerator, then your horizontal asymptote is y equals 0. Okay, so anytime you have zeros left over in the denominator. So if they both cancel out, you'll have a horizontal asymptote at whatever answer you get. If there's no x's left in your answer, quote unquote, that will be your horizontal asymptote. If you have x's left in the numerator, you don't have a horizontal asymptote. And if you have x's left in the denominator, your horizontal asymptote is y equals 0. Okay, that was a lot. Let's look at vertical asymptotes. So vertical asymptotes happen when you have x's in the denominator. So for example, let's say we have y equals, I'm going to go ahead and write out a factored polynomial. So 3x plus 7 and then x minus 4. So this would be a polynomial in the numerator, and it's a really good idea to start by factoring it. And so I'm going to write one out that's already factored. And let's say 2x minus 5 and then x minus 4. Okay, so your first step in finding vertical asymptotes up and down is to factor the numerator and the denominator. Okay, and then cancel out what you can. Okay, so we can cancel out this. So this term right here, this factor, represents where we'd have a hole. Okay, so we would have a hole in our graph at x equals 4. Because if we plug in 4 into this factor right here, we would get 0. And remember, the denominator is not allowed to be 0. So we would have a hole in our domain right here at x equals 4. Because 4 minus 4 is 0. 0 is not allowed to happen. Now to find our vertical asymptote, we would say this other factor, okay? This other factor is 0, because that's where we're going to have a vertical asymptote. Because remember, factors in the denominator are not allowed to be 0, because then we're dividing by 0. That's not allowed. So 2x equals 5. We're solving for x. X equals 5 halves. This line at x equals 5 halves. So if we're graphing, go over to 5 halves. 1, 2, 3. So 5 halves would be about right here. This vertical line, x equals 5 halves, is a vertical asymptote. Okay? So you can find vertical asymptotes this way. Make sure you look at all the factors of the denominator, but make sure you cancel out the ones that cancel in the numerator, because that's where you have holes. And then the ones that are left over are your vertical asymptotes. Great. Let's go back to the textbook. See if there's anything that we missed. Okay, so we have horizontal asymptotes And you can check this out. It shows limits and vertical asymptotes you can find by factoring, canceling out what you can. Very good.